Welcome to Module 7, the final module in the no-code blueprint, Getting Started. In the closing module, I'm going to provide some additional guidance and many tips to help make your software development endeavor more successful and hopefully more enjoyable too. So as someone taking this course, you might be just interested in no-code development and wanting to know more. You might be a hobbyist, having a play around with some no-code tools. You may be a citizen developer in a corporate environment tasked with building some of your own solutions. You may be an IT manager prototyping a solution before formally starting a software development project. You may be a startup founder or entrepreneur wanting to build and launch your own product. Or you may be someone who we've not spoken about yet. The point is that you may be committing to a no-code software development endeavor to varying degrees. And what follows are guidelines that you should consider if you were taking on a more serious software development project, perhaps akin to traditional software development where you are not using no-code tools. If you're just a hobbyist, then many of these tips will be irrelevant to you, but chances are that you will lie somewhere between these 2 points, or else you wouldn't be taking this course. So let's get into the detail. Trying to do everything at once or trying to be everything to everyone will see your project end in failure. I really recommend identifying a minimum viable product, or an MVP as it's referred to. And an MVP is a version of your product with just enough features to be usable by early customers who can then provide feedback for future development. A focus on releasing an MVP means that developers will potentially avoid lengthy and unnecessary work. And here are some tips that you can use to identify your MVP. First and foremost, as we've spoken about before, you need to identify the core problem you're trying to solve for your customers. You then need to clearly define your target market and customer segments. So who are those people that will be using or buying your solution? Third, you need to identify the key features and functions that are necessary for your MVP to solve that core problem that your target market or customer segments are trying to address. Number 4, you need to then prioritize those features based on needs and feedback from customers or users. Number 5, you need to then develop a prototype or a proof of concept to test with a small group of customers. Gather feedback from the early adopters or these early customers or early internal adopters and use it to improve your MVP. Still, make sure to keep your MVP as simple and as streamlined as possible to reduce development costs and time. Especially, if you're building this as a hobbyist, you don't have as much, you've got spare time only. This is really going to help you. Next, focus on creating an MVP that can easily be scaled and improved upon in the future. You sort of don't want to back yourself down a one-way alley and not be able to grow on what you've built. Then you can continuously gather customer feedback and use it to iterate on your MVP. And finally, you need to measure and track key metrics to determine your MVP success and areas for improvement. So think about those as you go into this process, and this is really, really going to help you get going much quicker. This looks confusing. There's a lot of stuff here, and this is just a subset of no-code tools available. I wouldn't get too stuck on the detail at this point, but in the same way that traditional coding projects will need to choose a combination of technologies, typically something to build the front end, something to build the back end, something to build the database, you will need to similarly choose your no-code platform. However, you may find a product such as bubble.io which does all of these, or you might use something like Webflow to design the front end and Airtable to design the database. So really think about the combination of different tools or using a single tool to address your requirements. So what are those requirements? So these are the things you need to think about. One, you need to really understand your project requirements and goals. So what are you looking to achieve on this no-code journey or this thing that you're building? Secondly, you need to then research and evaluate different software development stacks, i.e., will you be using 1, 2, or 3? Which ones are going to suit your needs the best? Think about scalability and performance of the one you are choosing or potentially thinking of choosing. And we spoke about scalability and performance in one of the previous modules. Then look at the availability of resources and support for the stack that you might be choosing. So something like bubble.io has been around for ages. WordPress has been around for ages. There's loads of community. There's loads of online training. There's loads of resources available to help you when you get stuck. Some of the newer platforms, for example, may not have that community or that amount of collateral available. So, think about how the resources you need to kind of learn the stack and overcome any challenges. Then, take into account the ease of learning to use the tool. For example, building a user interface in Glide is very easy, but you don't have as much flexibility as you might want. Whereas building it in bubble.io is more complex, takes time to learn, even although it's no code, but gives you way more flexibility. So think about you and your skills that you need to build, and also if you're involving others, about their skills. Think about how widely the stack is adopted. Does it have that large community as we've referred to before? And then think if the stack is a good fit for your specific industry or use case. So, for example, if you are working in a regulated industry like finance or insurance or healthcare, think about some of those very specific requirements and make sure that your technology stack will support those requirements. Then you need to evaluate the cost and licensing. It's one thing developing as a hobbyist and working on the free version, but if you are to scale this and unlock the full feature sets of these stacks, and you are wanting to charge customers, think about what it's going to cost you versus what you might be charging. Also take into account the security and stability of the stack. So certain stacks where you are using, or certain products where you're using the free version, don't really have any enforced security model, and this is not something you really want to use for a production type of solution. So think about that as well. And then before you make a big decision and embark on this journey or your project, test the stack with or tool or various tools that you're choosing or wanting to choose with a small proof of concept project before you finally commit to that stack, just to make sure you don't invest unnecessary time and money in something that might not work. Next, estimation, and depending where you are on the scale of no-code developer, for example, those personas I laid out before, are you a hobbyist or are you an IT manager, you may or may not want to estimate your project. Unless you're a pure hobbyist, you'd probably need to perform some level of estimation, and here are some guidelines to help you get that estimation right. Again, like we had in the previous slide, understand the scope of the project. Gather those detailed requirements and information about your product's requirements, the features you want to build, and the objectives you want to achieve. Then break the project down into smaller tasks. And now you will have seen this on the Kanban board and demonstration that I did. Divide the project into smaller, more manageable tasks, such as user stories or use cases. Again, we spoke to those in some previous modules. Then estimate the effort required for each task. Assign an estimated effort in hours or days for each task, taking into account factors such as complexity, uncertainty, and dependencies. Then use some historical data. You can look at data from previous projects that you may have done to inform your estimates and identify patterns or trends that can help you make more accurate predictions. So for example, previously you may have found implementing a security model really difficult. Take that into consideration when you estimate the time that you're going to be spending on building and implementing that security model. If you have a team involved, get them involved in the estimation as well. Get input from the development team members who will be working on the project, as they will have a better understanding sometimes of the effort required for various tasks. Be realistic, be honest about the level of uncertainty and risk involved in the project, and adjust your estimates accordingly. I've worked in the technology sphere for 30 years, and I've worked with technologists for most of that time, and I've found technologists always to be optimistic when thinking about how long a task will take or how long it'll take to achieve an objective. So be realistic and be honest about that. Then think about using some estimation techniques such as planning poker or 3-point estimation to arrive at a consensus estimate, of course, if you're in a team. So some good tools there: t-shirt sizing, planning poker. That really helps you kind of get a feel for what it is you're going to be building in terms of effort. Account for contingencies. So you need to build in contingencies for unexpected events or changes in the project. And this is true in a formal project environment, but also as a hobbyist. So you may think you can do things on, you've got a Saturday and Sunday to build your project on the side, and you might have it published by X date based on that. But arguably something's going to come up at some stage or some weekend. You're not going to be able to work on your project, and that's going to push your delivery date out. Then, be sure to review and update your estimates as you progress through the project. So regularly review them, and also not only as you progress, but also as new information becomes available. And then finally, if you are working in a bigger team or an environment with other stakeholders, be sure to communicate your estimates. So communicate them clearly and transparently to all stakeholders and ensure that they understand the level of certainty involved. Also true if you're delivering this to a paying customer, for example. Next, think about your planning. So having estimated your project, you should be planning it. And if you don't plan, your project will never finish, even if you're a hobbyist, and especially if you're a hobbyist. So when planning, think about the following. Again, clearly define your project goals and objectives. You will have done this already in some previous steps, but now is an opportunity to either refine those or validate them. Make sure that they're aligned with what it is you're wanting to achieve, what your customers wanting to achieve, what your organization is wanting to achieve. So whoever you're building this thing for, make sure that is aligned with what they're wanting to achieve. Make sure you understand the scope of the project, again, working through your detailed requirements, your features and objectives. Also think about the risks associated with the project. So identifying your potential risks and develop a plan to mitigate or manage them effectively. So for example, there might be a feature that you're wanting to implement and you assume that your chosen no-code tool can do that thing. When it gets down to the crunch, you may find that you can't do that thing. So what is your plan? Is your plan to move to another stack and redo a whole lot of work? Is your plan to get someone to help you with that? Is your plan to go from no code to code just to do that thing? Think about all of these things that might become challenges. Make sure you also plan to spend some time testing and quality assuring, especially if you're going to be charging for this application or this product that you're building. Also, depending on how critical it is to an organization or an individual, it needs to be properly tested. And then finally, consider the resources that you might need in the timeline. The obvious one is time, but consider the things like, people that you might need, some subject matter experts, equipment, budget to pay for some of these no-code tools, and make sure you develop a realistic project timeline that takes into account all of these things and some of the key phases and milestones that you want to hit. You may have heard about a term called technical debt, and in software development, technical debt is really the implied cost of additional rework that you cause by choosing an easy solution now instead of a better approach that would have taken you longer. And, this is analogous to monetary debt. If technical debt is not repaid, it accumulates interest, making it harder to pay off later, or in the technology world, making it harder to implement changes later. Again, there is a fine balance. We spoke about the minimum viable product earlier on. So it's important to find that balance, so on one side, you're not incurring technical debt, but also you're not over-engineering things. Remember, perfect is the enemy of done. As mentioned in an earlier module, there are various types of documentation. Generally, this will either be system documentation, documentation to support the operation of your software, and then finally end user documentation. Regardless of which set you're creating, here are some best practice tips for producing that documentation. First and foremost, understand the audience you're producing that documentation for. So remember, we talked about people implementing your software, people using it, and people maintaining it. So think about who will be reading that documentation and tailor the language, tone, and level of detail accordingly. So for example, if you're creating documentation around maintaining your solution or extending your solution, that's going to be pretty technical in nature. But if you're developing an end user guide, it's going to be more business focused and less technology focused. Be clear and concise. So use simple and straightforward language. Try and avoid jargon and just be as concise as possible. You know, if someone can get what they need from a paragraph rather than reading 4 pages, go with a paragraph. Think about using visuals and examples. So use screenshots, use diagrams, use examples to clarify your instructions. And this makes the documentation more engaging as well, and not just the mountain of text that someone has to read. Organize the information. So in the same way we talked about indexes and keys in tables and data structures, do the same. Organize the information in your document in an easy and logical way to follow. Use headings, use subheadings, and use bullet points as necessary. You need to test and update the documentation. So, you know, test it with actual users who can identify any issues earlier on or areas for improvement. And make sure you update it regularly, either as your product changes or perhaps the no-code platform changes. Use the right tools to create this documentation. So using appropriate tools for creating and maintaining the documentation, such as something like Word or Google Docs. There's tools that can help you author help files. There's knowledge management systems. All of these things, like Notion, for example, you know, it's easier to keep updated when you have an online version than where you distribute, for instance, PDFs or Word documents. Make it easy to find information, you know, so use a clear and intuitive structure, include a table of contents, make the document searchable, and make sure your headings and labels are meaningful. Make the documentation available, so make sure that the documentation is accessible to all users, including those with disabilities, by following some best practice guidelines, usually developed for doing web kind of development and documentation. Provide context within your documentation. So, you know, make sure you give the user context by explaining the purpose of a feature or function and how it relates to other parts of your product, as well as any best practices or tips, and also how that feature or function relates to the problem they're trying to solve. And then, as with anything, continuously improve, you know, continuously review the documentation, gather feedback you get from users, and make improvements to ensure that it remains accurate and helpful to users over time. And this all goes a long way to help drive adoption of your product and make it successful with happy customers. Finally, end user support. Think about how you will support the users of your application. So, you know, if you're a hobbyist with few users, your approach will be different to a professional with several hundred users in an organization. So just make sure you're structuring your support accordingly. So, you know, whichever scenario matches yours, or if it's a scenario somewhere in between, consider the following things, you know, when you design your end user approach. Firstly, think about who that support team is going to be. Is it going to be you in your spare time, or are you going to have a dedicated person or people to support end users? And make sure that that team has clearly defined roles and responsibilities. Then you need to set up your support structure. So set up a structure that includes the formalized processes for handling support requests so these don't get lost, escalations where things can't be solved and need more attention or need help, and also how issues are resolved. Make sure that you communicate with end users, so establish clear channels for end users to report issues, ask questions, and provide feedback. So a good example of this is someone opening a ticket, for example, that says, I've got an issue with the software, or I'm stuck with this thing. They submit a ticket, make sure they get a response to that ticket, acknowledging receipt of it, and telling them or describing to them the next steps. So clear and concise communication with end users. Also think about giving users of your product some self-service resources. So give them self-service guides, give them a knowledge base, give them FAQs, frequently asked questions, and really empower them to find solutions on their own. This is beneficial in two ways. It takes the strain off of you or your team if you have a support team, but also really grows their skills and abilities when using your software. And then finally, as in the previous point, continuously monitor and improve. So do this around your support processes, do this around the way you gather feedback, and use that to identify areas for improvement and make the necessary adjustments. What I've included in the resource page here is an article on Indie Hackers, which is generally, Indie Hackers as a platform is a fantastic platform. So I would encourage you to spend some time there. This one specifically is written by the founder of Indie Hackers, tips for providing stellar customer support. There's some really good content in there, along with some thoughts around tooling and those sorts of things. So take a look at it. As I said at the start, this is the last module in the course, and all that is left for me to say is thank you. Thank you for coming on the journey with me through this course. I hope you found real value in this, and I hope that you can take what you've learned, put those learnings into action, and build out whether it's a hobbyist product or a product that's going to become a business and make it a success. So again, thank you so much for spending time with me, and feel free to get in touch with questions and also your wins and losses. I look forward to hearing from you.